In this video, we introduce the concept of joining two tables together in order to retrieve information from both tables in a single select query. You should be logged in to SSMS to our class server using the grocery store database login. The credentials are in course documents. Go ahead and do that now so you can follow along. I am logged in using the grocery store login credentials. I'm also logged in using a different set of credentials. Be careful if you are logged in more than once that you are aware which query windows go with which login. Notice that at the top of the query window in the tab, it will tell you which login is associated with that query window. This is significant because you have different permissions depending on how you logged in, depending on what credentials you used. A brief review of terminology. A table is something that contains a collection of entities in the real world. It consists of rows and columns. A column is also referred to as an attribute of the table, or sometimes a field belonging to that table. Each row in a table describes one instance of something in the real world as part of that table. We also use the term relation to refer to a table. That means that when we say relational database or RDBMS, we are saying our data is stored in tables. We are not saying the tables are somehow related. We are not saying there are foreign keys connecting tables together. All we are saying is that a relational database, an RDBMS, contains data stored in tables. There are other kinds of databases that store data in documents or in objects or in JSON syntax, but for our purposes, everything we do will be in an RDBMS or a relational database management system, which in our case is Microsoft SQL Server. You should know your keys. Hopefully you've read the book. Hopefully you're familiar with these terms. Let's review them briefly. A primary key is an attribute that uniquely identifies each row in a table. All our tables will have a primary key. Under no circumstances will we have a table without a primary key. You may read in a book that the primary key is not always used for all tables. In my experience, that does not prove to be true in the real world. I'm sure there are some examples where a table without a primary key is useful, but I'm not familiar with those circumstances. Two kinds of keys, surrogate and natural, are important to us. The surrogate key will be created by us and does not reflect anything in the real world. That will be our primary key. A natural key is provided by the real world scenario that we're modeling, and that will reflect something in the real world. That may be a social security number to uniquely identify a human being. It may be your student ID to uniquely identify you at your university. It may be a number that's made up by your employer to uniquely identify you. Even if it's made up by your employer, it is still a natural key because it comes from the problem domain. It comes from the thing that we are solving for our customer. A foreign key is an instance of an attribute that connects to a different table. A foreign key in one table connects to a primary key in another table. It doesn't really fall into the category of primary, surrogate, or natural. It's kind of on its own, but it's still referred to as a key. We'll talk more about that in great detail because it's crucial to understanding how to extract information from multiple tables in a select statement. The foreign key connects to another table. A table with a foreign key attribute will have a value in that foreign key attribute that is the same as the value in a primary key in another table. We do this so we don't have to have repeated data across multiple tables. We don't want your name appearing hundreds of times in our database because you took hundreds of classes from us. We want your name to appear once in our database, and we want a foreign key referring back to you each time you take a class. The reason we do this is because there will be multiple opportunities to make mistakes if we don't. We update records all the time, we delete records, and we may do that incorrectly. We may lose crucial information forever if our foreign keys are not structured properly. We will go into this in more detail in IT 3060, which is the second semester of this sequence. Suffice it to say for now, the purpose of a foreign key is to reduce data redundancy and reduce update and delete errors. A table that you create can have 0 foreign keys if it does not connect to any other tables, or it can have as many foreign keys as necessary to model the information in each row of that table. This is up to the database designer. That may be you, or it may be up to someone else who gives you that design because they have a better understanding of the problem domain. The better understanding of the problem domain is provided by someone called the domain expert. This is a term that I use to refer to the person or persons or group or document that tells you what you're modeling in the real world. Your job then becomes consuming that information from the domain expert and translating that into a database, and then writing queries against that database to extract useful information for the domain expert. This is a symbiotic relationship. You depend on them, they depend on you. Without a domain expert, you cannot hope to provide a useful system under any circumstances. You may be the domain expert in rare circumstances if you're creating a database for yourself, or if you're creating a database for a business that you understand thoroughly. In most situations at work, someone else will be the domain expert and they will be providing with this information. I also refer to this person as your customer because that defines the relationship that you have with them. You are providing them with a service. That person may be your boss, your supervisor, your department, but they should still be thought of as your customer because you are providing them with a service, regardless of whether they are paying you in money or in pats on the back. Let's digress for just a moment and discuss some design rules that we will follow. I am using databases in this course that I have designed, and I follow a set of rules that make my life a lot easier. These rules are based on things that other people do to design their databases, based on my experience, and they will benefit us because we will all be talking the same language, and we will be doing much less detective work trying to figure out how tables connect, what foreign keys are, and trying to write select statements when we're not really sure what's going on. I published a document on Blackboard. You should have this document with you at all times. You should study it. You should put it under your pillow at night. You should take it to Kroger with you and read it in the checkout line. And you should understand the terminology because these are the rules that I follow when I create a database. If you understand these rules and follow these rules, we'll be talking the same language. I will be the first person to tell you not everybody follows these rules. Some people may disagree with these rules. When you venture out into the real world and you're employed as a database analyst or a database programmer, database developer, you may be given a different set of rules. That's fine. These are just the rules we will use in this class. They are not guaranteed to be universal. They are not guaranteed to be perfect or complete. but they are very helpful for what we will be doing here. Here are 3 important design rules. Every table has a primary key. As I mentioned earlier, you may read in books that there are tables that don't have a key, but in my experience, I have not found that to be the case. Our primary key will be surrogate. We will create it using an auto number, auto increment field. SQL Server will maintain it, and we don't have to worry about it. Every table has at least one natural key. In other words, every table that you create represents some entity or collection of entities in the real world. Each of those entities must be uniquely identified somehow. In a student database, all the students must have some unique identifier, else how would we find them in the table? In a product database, every product must have a product UPC code, a manufacturer's code, a vendor's code, something that connects to the real world. Without that, then we don't know what records we're looking at when we scan through that table. We will follow these rules without variation throughout the semester, and I have found that they serve me very well when I do development in the real world. Let me emphasize again, you may encounter developers, designers with different sets of rules. That's okay. These are my rules. I've developed numerous databases for customers. I've made a living writing databases, writing queries, designing the back ends of systems, the underlying databases, and these rules have served me well. That doesn't mean that they're the only set of rules. That doesn't mean there are other rules that are just as good or perhaps better under certain circumstances. To this point in your development, after a few weeks in the course, you should recognize these clauses. You should know how to write a select statement, using from to reference a table, using where to set a filter on the table, using order by to define the sequence of rows returned by the query. These terms should already be familiar to you. To this set of terms, we're adding the syntax join, which allows us to extract information from multiple tables after connecting them in some logical way. As you've seen in previous lessons, we broke the query down, or the question that we were answering down, into multiple parts. And then we easily map those parts into the clauses of the query that we understand. I'm adding at the bottom in red, if there are multiple tables, how are the tables joined together? So you as a query designer, as a query writer, may have to do a little investigation, may have to dig into the structure of the tables, may have to ask for supplemental information about the database in order to determine what the multiple tables might be and how those tables are joined. When you finish this work, you should be able to explain the joins that you've used. You should be able to explain the 3 types of joins about which we are concerned. There are other joins, but these are the 3 that we will emphasize: inner, right, and left. And you should know when to use each join. The knowledge of which join to use is based on the constructs of the tables along with the question that you're trying to answer. I'm going to keep the question simple. I'm going to keep the table structures simple. And if you follow the rules that we've defined and you read the conventions that we're following in the document, if you study these conventions, you'll have a very good idea of what my tables are doing. You will understand when to use a join, you will understand the impact of each join, and you will understand the expected result from each kind of join. The 4 kinds of joins that we will address, and the first 3 are significant. The last one is just a warning of what could go wrong, are inner, left outer, right outer, and cross. Inner, left outer, and right outer are by far the most popular kind of joins that we will use. The cross join is dangerous. I created a supplemental video illustrating what happens when you do a cross join, and the reason I do this is because a lot of students, a lot of new developers use cross joins by mistake, and therefore I want you to be aware of what happens when you do it. I want you to recognize the results, and I want you to avoid using the cross join. So it's kind of a buyer beware when you are creating a query. Be sure to look at that other video describing the cross join in detail in this lesson. Here's a single slide about the cross join. As I said, there's another video. We won't spend a lot of time on this, but suffice it to say that you multiply each record by every other record in the other table, and you come up with a very, very large result set, which is rarely what you want, and at this point something you should avoid. How do we join tables together? We can only join 2 tables at a time, but the result of that join can be joined with another table where we can create a string of joins, if you will, and combine multiple tables together in that fashion. But a single join statement can only combine 2 tables. We look for a common column between the 2 tables, which would be a key, typically a primary key in one table, and a foreign key in the other table. So when you are asked to solve a problem, to answer a question, to write a query, you figure out how 2 tables are joined together once you've determined that the 2 tables contain the information that you need. We will stop here. Please continue on to the next video, and we will continue with these slides.